Hello, friends, and even you detractors. You know that I have believed in the flat earth for about a year, a little over a year. And I still do believe in the flat earth. I think the most convincing argument is that you cannot see any declension in the horizon, no matter how far off something is, when you use high-powered cameras or telescopes. You can see islands that are 100 or more miles away. You can see ships that would be well under the horizon when they're miles out to sea. And then, of course, there's the famous video of the Chicago skyline from across Lake Michigan. And there's other convincing proofs, I think, and I've put quite a few of those on my channel. But today I want to bring you a problem that we have. The flat earth has a problem. And all of you are probably aware of the Gleason Map, the one that shows the North Pole as the center of our Earth, and then continuing outward to a ring of ice around the perimeter of the world. And of course, like any plate, the center would be the circumference at the center would be less than that at the outer edge. And so you would expect to see the distance around the Earth increase as you move away from the North Pole. The problem is, reality shows us that that is not, in fact, true. A new friend that I gained from my flat Earth and Christian teaching videos, wrote me with some experiments that he did. He lives down in Australia, and he did some experiments based upon where he lives, which is at Perth, and came to the conclusion that the circumference around the world, around the Earth, basically at the latitude of Perth, which is very close to the latitude of Sydney, would be right about 21,000 miles, according to his calculation. I did the calculation and I came to 21,247 miles, and I want to share with you how I came to that conclusion. First, I'm going to go through a couple other calculations with you. And for ease, we're going to use the standard globe to consider this idea. I'm basically going to start this idea by considering a couple of cities down here at the equator in South America. Okay, so you could get out your globe or any map, and then I want you to look at these cities. I'm going to go through the details with you of these two cities. It's going to be Macapa, Brazil, and Quito, Ecuador. The basic idea of this experiment is this, and you can go to timeanddate.com to get the figures. That's what I used. Now, of course, if the figures at timeanddate.com were inaccurate, if they were actually bogus figures, then of course that would mean that these results are bogus. However, my friend from Australia said that the figures that he looked at correspond to his reality in Australia. The figures that I looked at correspond to my reality in South Central Missouri, because I used the two cities of St. Louis and Kansas City, Missouri, which are both just a little bit north of where I live. And the figure, which was the sunrise time for each of those cities, corresponds relative to where I live, just south and central of those two cities. But let's go back to Quito, Ecuador, and Macapa, Brazil. Now, this was yesterday's figures for me. I looked at it at these yesterday. Quito's sunrise was at 6:08 a.m. and the latitude of Quito is 0.1807 degrees south of the equator. Macapa, the sunrise was at 6:18 a.m. and the latitude of Macapa is 0.0356 degrees north. So they're not exactly on the equator. That means they're not exactly at the same latitude line, but they're very close. So the result that I get is not going to be exactly right, but it's going to be close enough to give us an idea of what's going on. You also have to have an idea of UTC, which means Universal Time Coordinated. Quito is UTC equals 5, and Macapa is UTC equals 3. So when you have a sunrise, for example, at Macapa at 6:18, and then a sunrise at Quito at 6:08 a.m., you have to factor in that 2-hour difference in UTC and realize then that the sunrise difference was exactly 1 hour and 50 minutes. Now, this 1 hour and 50 minutes is critical for the calculation, because the next thing that you go through is to figure out how far away from each other these two cities are. And you can get all these distances on the internet. And then, of course, I did get the figure off the internet, but I also knew from personal experience that the figure I got from the internet was exactly right, because I've driven St. Louis to Kansas City many, many times, and they're almost directly across from each other on the same latitude. Anyway, the distance between Quito, Ecuador, and Macapa, Brazil is 3,045 kilometers. Sometimes in my figures I'll use kilometers, and sometimes I'll use miles. And of course you have to do the corresponding numbers to figure it out versus for kilometers or miles, depending on which one you want to use. I'm used to miles, so I always convert back to miles if I use kilometers. So basically, using some relatively simple math, I determined that if the sun moves 120 or moves 3,045 kilometers in 110 minutes, that would be the distance of the sun that you see moving from Brazil to Ecuador in that amount of time. Then using a simple ratio mathematical formula, you come up with a figure of 39,862 kilometers, which is, converting to miles, 24,769 miles. Now, today I looked up how many miles does science say that the circumference of the Earth at the equator is. Well, it's 24,874 miles. So the figure I came up with using this very simple experiment was only 105 miles off of what accurate scientific measurements say that it is. And that simple technique gave me an error of less than 0.5% from what the actual amount is supposed to be. Okay, now let's, as I said earlier, if you go south of there, the circumference of the Earth should increase rather than decrease if we are, in fact, on a flat Earth that is shaped like a bowl or like a dish. So I'm not using my friend's figures. I'm going to use my own. And they actually corroborated his figures. So we're doing this measurement from Sydney to Perth, Australia. And this was actually for the April 26th date, which is my date today that I'm doing this. It's already April 26th over there. Sydney sunrise was at 6:25 a.m. and the Perth sunrise at 6:44 a.m. Sydney is at a latitude of 33.8688 south latitude. And looks like I forgot to write down the Perth latitude, but they're pretty close to the same latitude. I know my friend used, he said basically a 33 south latitude for his place where he lives, and that's at Perth. So anyway, again, they're not exactly at the same latitude. They're close. So these figures are not 100% accurate, but they're accurate enough to show us the problem, and that's what I'm trying to get across today. So Sydney is at UTC equals plus 10, and Perth is at UTC equals plus 8. That's 2 hours difference, and therefore the difference in time of the sunrises today from Sydney to Perth was 2 hours and 19 minutes, or 139 minutes. Now, the distance from Sydney to Perth is 2,051 miles. And here I'll go through the simple calculation using the ratio just so that you can understand it if you didn't understand what I meant before. You have 1,440 minutes in a 24-hour day. If the sun travels 2,051 miles in 139 minutes, then the sun would travel 21,247 miles in 24 hours. And the way that works is you just write a ratio that puts 2,051 over 139. That equals x over 1,440. You see the denominator in both fractions is the number of minutes. The numerator in both fractions is the number of miles. And you just solve for x. And so x comes to 21,247 miles. Now, 21,247 miles is less than the 24,769 miles I came up with between or for the circumference at the equator. So you see, that's corresponding with the globe model that shows that from the equator, the circumference around gets smaller. The equator would be the largest circumference on a globe Earth. Now, the icing on the cake, of course, is the St. Louis to Kansas City calculation, and this is what that is. St. Louis is at a 38.627 north latitude. Kansas City is at a 39.0997 north latitude. That's very close. They're very close in the same latitude. Yesterday, sunrise in St. Louis was at 6:11 a.m. Sunrise in Kansas City, Missouri was at 6:28 a.m. Now, we're in the same UTC here in Missouri, so it's the same UTC between St. Louis and Kansas City. So there's no addition of hours here. I just simply look at the difference in minutes. Well, there was only a 17-minute difference between the time of sunrise between St. Louis and Kansas City. So now what we do is we look at the distance between St. Louis and Kansas City. That distance is 239 miles. Then using the same ratio idea with that number of minutes and that number of miles, we come up with the circumference at basically the 39th north latitude of being 19,647 miles. Now notice that figure is even a little bit smaller than the figure I came up with between Sydney and Perth. And that makes sense because, see, Kansas City and St. Louis are 39 degrees north of the equator, whereas Perth and Sydney are only 33 degrees south. So we're another 6 degrees north, or a 6-degree difference up here in Missouri than he is down in Perth with respect to the equator. So it would make sense that the circumference on a globe model, that the circumference would be less, a little further degrees north, as I am here in Missouri. Well, that's a problem, isn't it? I'm not suggesting we throw out the whole idea of a flat earth, but what is the reality of the earth in which we live? Something that occurs to me is, and I've always wondered, when the angel appeared to Ezekiel, there were wheels within wheels. And I talked to my friend in Australia, and he said the same thing about the constellations that we say here in the Northern Hemisphere. And I don't know how many of you have realized this, but if you look at the constellations, just think of Orion. It traverses the sky from the east to the west. Yet, if you look at all of the time-lapse videos of the stars looking toward Polaris in the north, you see the stars moving the opposite direction, at least at the bottom. At the bottom, they're moving from the west to the east, and then they go around in a counterclockwise circle and then move to the east to the west when they're above Polaris. My friend down in Perth, when he looks up north, he sees Orion, and it's moving from the east to the west, just as we would expect, even though you've heard that the stars move in the opposite direction in the southern hemisphere. But then when he looks down at his south pole, he sees the very same type of thing happening that we see, where there's a different movement, apparently. So what are we seeing? What is it that we're actually seeing? What is this reality that we live in? I think we're onto something, and we are beginning to perceive reality as God made it, and we're not just taking science's answers for everything. And I think that's wise, because look at the lies, the clear lies we've been told by so many for so long. But this is a flat earth problem. And now we need to take the problem and find the solution. Now, if I were a man of means, millions and millions of dollars, I would probably be able to solve this dilemma, because I would be able to go on excursions and do experiments and so on that would enable me to figure it out. But to look at it from my perspective, with the simple tools I have, and with my simple ability to travel short distances, there's much that I cannot know. But some of you do have means. Some of you will have ideas. And a lot of times an idea is a simple idea. A very simple idea could give us a breakthrough in this. So let's continue to seek the truth, and then let's share what we find with each other. We don't lie. This is not about trying to get one up over somebody else. It's simply a matter of wanting to know the reality in which God created us. So, let's see where we go from here.